Okay, now here is reaction 1 of the worksheet. It's the same worksheet. I really hope you have it in front of you, and I really hope you have the reference tables in front of you open to your periodic table so that you've figured out all the charges. The majority of the work comes before you click anything here, figuring out what all the charges are. Most of you who submitted this one got this one right or almost right. What I wanted to do here, though, is to limit your choices. Now, here's something. Reducing agent, oxidizing agent. When you add the word agent, the meaning is flipped. Whatever element is reduced is also called the oxidizing agent. Remember? Like Secret Agent Man, because that's his mission. Whatever element is oxidized is also called the reducing agent. This little chart is set up the same way for every question. So think about what must always be true. Think about which two of these would always have to be the same. It's not these guys, right? It's not. These would not be the same. The element reduced would not be the reducing agent. Hint, hint. Okay, so let's actually do this one. I think it's this. What I would have in front of me is the zinc here that's by itself 0. The pure elements should jump out at you. Put those zeros on first. So this first zinc is 0 and this last hydrogen is 0. So that tells me that it's obviously zinc and hydrogen that are changing. I put chlorine in here as an option because I just put all the elements as an option, but he's not involved. In HCl, if I look at the probable charges, it's the two most likely charges for hydrogen and chlorine, +1 and -1. And same thing for the zinc and the chlorine. Zinc wants to be +2 according to the periodic table. Each chlorine would love to be -1. That math works out, right? +2 and 2 -1s add up to 0. What does that tell me? That tells me that the zinc goes from 0 up to +2. So this here is the first thing I figure out. The element that's oxidized is zinc because his charge goes up. He is obviously going to also be the reducing agent because I add the word agent and the meaning flips. If the hydrogen goes from +1 down to 0, he is reduced. Here's the thing about reduction. You might want to start with reduction instead of oxidation. Look for the reduction first because the reduction is actually what it sounds like. If the charge goes down, that is the reduction. That is the guy who is reduced. It sounds more like what it is. So hydrogen +1 down to 0, he is reduced. He is also the oxidizing agent. Okay. What else did I want to say about this? I want you guys practicing this. I don't really care what grade you get on this. Everybody should have multiple submissions and eventually get 100. That's great. Don't go clicking through this quickly. The whole point of this is that you can find the right answers if you do multiple submissions. I know you can find the right answers. I really, really, really want this to be a teaching tool. I want you to use this to teach yourself whether you're getting the ideas. Now, here's an even more important thing. Check out the next version. It's a drag and drop. And the biggest mistakes we've been making for the people who submitted this worksheet is including too many things in the half reactions. I think I've said this, I think we have it in our notes, but I'm going to reiterate it. You should only see 3 things in the half reactions. The one element that is changing in that half reaction, its charge is changing, and the electrons. That is it. Just those 3 things. The one element changing, its charge is changing, and the electrons. Now I can make that statement more specific for oxidation or reduction. So for the reduction half, we should only see the element being reduced, his charge going down, and electrons being gained. That's it. Nothing else. You guys are including too much other stuff in these half reactions in general. So let's focus on that, the reduction. The hydrogen is reduced. So I'm only going to include the hydrogen. The hydrogen goes from plus 1 down to 0. Oh, but wait, I need an arrow, so I scoot him over, and here's an arrow. I still have more spaces. Reduction is GER, G-E-R, gain of electrons, and the other rule is I always put the electrons on the side with the higher charge. So I want 1 electron on the left side here. So I'm going to scoot these guys over, and I'm going to have an electron here. And how about an AND sign between the two reactants? And that is what my reduction half reaction looks like. Keep it simple. Don't worry about balancing right now. In fact, just don't worry about balancing. Okay? If you do this, the balancing becomes obvious at the end. Okay, oxidation. Who did I say was oxidized? Zinc. Okay, zinc starts as 0. And then he goes up in charge to zinc positive 2. Okay, add electrons to the side with the higher charge. Or I'm thinking Leo, loss of electrons is oxidation, so they should show up on the right. I'm going to guess 2 electrons. And that's how we do it. Now, this is obviously the easiest one. The other ones are harder because the charges involved are more complicated. Look for the manganese guys, the nitrogens. Those guys often change. But this is the general setup of how this should go. And then when you submit it, you should be able to see the right answers. I think I did that setting correctly. And I don't so much want this to be an assignment for a grade. The grade should be 100, as I said, if you do multiple trials. I really care much more about whether this is making sense to you. I did a lot of work to make these drag and drops because I thought it might really stress the fact that you got to keep it simple. Keep it simple. Only include the zinc and the electrons. Only include the hydrogen and the electrons. Okay, I hope this helps, and we're preparing for our Topic 9 test on Thursday, and I hope that if you have any issues with Topic 9 or just want to practice, that you'll Zoom on Wednesday.